I like this. Hi, my name's Godfrey Nolan. Got a lot to get through, so I'm just going to dive straight into this. It's normally a hour-ish talk. We're trying to do it in 40 minutes, so this should be fun. So none of my wonderful anecdotes, so you're all should be very happy today because you won't be hearing any of those. Okay, so how do we get here? Well, we have the whole design of the Android DVM. It's a virtual machine, so with virtual machines, basically the premise is that you have one code, and that code runs on multiple devices. iOS is completely different. They have what's known as a FAT binary, and it has lots of different versions of the iPad, the iPhone 5, the iPhone 6, all munched together in a single IPA file. But of course, we can't do that on APK because there are so many devices. You'd have, I don't know, 45,000 different versions of the APK just to satisfy your entire community of Android devices. The things that we're looking for when we're trying to look at Android apps is we're trying to find the static information. And by static information, I mean the information that's in the code that you leave there. So that would be API keys, that would be encryption keys. And then the other piece of, the other thing that we're trying to look for is dynamic information. And the dynamic information is in the shared preferences or in SQLite databases. Basically, whatever the user is putting onto the phone as they're using the device. So that's, dynamic information. So I'll talk a little bit about Decompilation 101. I'm sure many of you guys will know this, but just to make sure we're all on the same level. So the way that Java works, as you compile your Java classes into a .dex file, into an APK, the Java compiler converts it into a classes file, and the DXer converts it to the DX. So back in the old days, what people would use up till probably about a year or 18 months ago was dex to jar, which was written by a student in China, and dex to jar turned it back into class files, and then you could use any sort of Java decompiler that had existed for almost the last 20 years now. It's changed now, so basically what you have is you have the second part of the process is much easier. Basically everybody uses JADEX. So you get your APK, you load it into JADEX, and away you go. So how do you get your APK file? The usual way that you get your APK file is that you take it off the phone. So you would do an ADB shell and pull the APK off the phone, and then that gets you the static information so you can do an audit of the APK. And then if you do a ADB backup, that gets you the information on what the dynamic information is saved on the phone. All these slides are up on SlideShare if you want to follow along, or if you want to look at it later. It's actually a lot easier to get an APK because if you use one of the many websites out there to download the APK, I typically use APK Pure, which I really like because it has a history of all the APKs. So if you download your APK, you can also see all the earlier APKs, which is going to be important at the end of the talk because I have a bunch of gists where we put up all the hacks well, not all the hacks, but a number of the hacks that we've done in the past on major apps, and if you want to follow along, you'll have to download the APKs that match those hacks that we've done, and they're old now. All the hacks that I'm going to talk about today have, by and large, all been fixed. Most of them will probably have been fixed for a year or two, so you'll have to go back for 3 or 4 versions of the APK to find out how the anti-pattern of how they did something, so that you don't follow the same sort of problem. Okay, so APK Pure, you don't need a phone. You just enter the package name, or you enter the URL from Google Play, and you just download it. And then you start up JADEX. The one that I'm showing here is the United Airlines APK. United Airlines, a lot of publicity over the last year where they started a bug bounty to ask lots of hackers and security analysts to come in to have a look at their APK. They were paying a lot more than normal. If you go to any of the bug bounty websites, you're typically talking thousands of dollars, but United Airlines was giving away fairly substantial air miles, up to 1 million air miles. Okay, so audit reports. The way that we got into this, I run a company called RIIS LLC. It's based out of Troy, Michigan, just outside of Detroit. But I've always been interested in lots of low-level performance things, and I wrote an article about Java decompilation in 1997, so I have this weird obsession with bytecode. So when Android came along, it seemed like the obvious thing to do is to take a look at how the APKs were put together and how we see if there was a way that we could get them back to class files and then just use the same tools that we used for many years before. We did a whole bunch of security reports. They're up on Decompiling Android. They kind of ended up as part of the book, Bulletproof Android. But most of these apps will appear in either the hotel audit that we did. We also did one on dating apps, which we did for a couple of years in a row now, which we release on Valentine's Day. And then there's a number of other general ones that we do out there as well. Okay. So the way that I'm going to approach this today is we're going to talk about the OWASP Top 10, which is kind of the de facto standard if you want to take a look at what you're doing for Android audits. OWASP is the Open Web Application Security Project. It's out in owasp.org. If you want to, it's under the Mobile Top 10 Risks. And the way that I'm going to do it is I'm going to talk about each of the different problem areas. So on the right-hand side, you can see what we're doing, and on the left, which area we're covering. On the left-hand side, I'm going to talk about what the problem is, give a couple of examples, and how you should go about fixing it. And then towards the end of the presentation, I'll just cover some newer things that have come about that you may not be aware of, that are outside like the OWASP Top 10, the miscellaneous stuff. So if we talk about weak server-side controls, what I'm using here is I'm using Herd Financial, which is one of the apps that is out there on the OWASP website. It's worth downloading and playing with just to see how different things work, because it shows you some great anti-patterns about how you should not be coding weak server-side controls. So a lot of what we need to figure out about on Android is not just in the area of the Android APK. You got to be looking what's going on the server as well. So you got to be looking at how your REST APIs are how you're forming them, how you're making sure that nobody is injecting certain things, changing certain verbs to get access to things that they shouldn't necessarily be allowed to get access to. So I'm using Burp Suite here. I'm calling up you can see it a bit better here. I'm calling up what the API is for Herd Financial. I'm looking at what my balances are. It's fairly typical. At the end of the month, there's no money left. So if I change the API to look at somebody else's account, I can then see what somebody else's account has. So obviously, if you're doing this in your API, you have issues. So you should be making sure on your server side that you are not necessarily trusting the client that it's always going to be authenticated correctly. You got to make sure that you're checking on the server that it's not accessing either a different area, a different module, or a different account number just by changing some simple numbers. And it sounds like it's a bit of an esoteric example, but it's not, because there's a lot of times people will use an ID just in an API, and hackers will basically look at what that ID is, and if it's not a GUID, what they'll do is just try 4 or 5 numbers sequentially to see if they can get any more information. We did an audit recently, and we just changed a couple of numbers, got a ton of warehouse information that we shouldn't have access to. Here's an example where I'm showing a social media app for an IoT device, and they asked us to have a look at what was, if there was anything that we could find on their app. We found that their IDs weren't secured, so if we used Postman or Burp Suite, we could change the ID, and you can see just if you look at where it says Detroit what, where basically is inserting some information that one of my interns did that to just basically see if they could get access to somebody else's ID and essentially control what information flow is going on the social media app. So the fix is to use GUIDs that map to IDs. Don't use IDs. Use something that can't be guessed. Be careful about what your REST verbs are. Make sure that they're, if you give them access to get, that you don't give them access to delete when they don't need access to it. There's more than one OWASP, so if you want to secure your server, have a look at the OWASP Web Top 10. And if you're using a cloud, the OWASP Cloud Top 10 is pretty mature now. It's great if you want to see some examples of what you should do to secure the cloud too as well, if you're letting somebody else take care of your backend server. And then the big lesson here of all is don't trust the client, verify. Don't trust, in fact, in all of this, don't trust the SDK, the third-party SDK. just make sure that you're verifying as much as you can. Download the APK, decompile it, unzip it, make sure that all the information that's in there is what should be in there. There's a lot of times when we've looked at APKs, we find that there's all sorts of things in the asset folder that probably shouldn't be there. So as I said, the big lesson of today is don't trust the client, verify wherever possible. Insecure data storage. So if we're doing an audit, one of the things that we look for is we look for if it says remember me, or if you turn it into airplane mode and you can still log in, that means that it's been saved somewhere on the device. And if it's been saved somewhere on the device because some business user has probably told the developer, we really need to make sure that this works on an airplane, where 9 times out of 10, that's probably not very valid, because the insecurity that you introduce because of that means that I can probably get access to the password because you're saving it somewhere on the phone. So that's one of the first things that we look at, is if somebody's got a nice little checkbox for remember me. This is using the Goat Droid example from the OAuth side too as well. That shows some of the username and password information has been stored in the shared preferences. Back probably about 3 years ago, we used to find a lot of apps that would store it in shared preferences, that they would just assume that nobody would root the phone, or nobody would do an ADB backup to get the information off the phone, or they would have an Android backup set to false, and then you could just access it in clear text and log into somebody else's device. This is assuming that you have access to the device. The last time I did this talk at Droidcon, somebody said afterwards that they didn't think that was a fair assumption, that you would have access to the device. But according to a report that came out probably about a year ago, Avast, the antivirus manufacturer, did a scan on eBay and found that there was, on any given day, up to 80,000, it's probably more, secondhand phones being sold on eBay, which means that if you're building apps, your apps are out there on eBay, and if you're putting stuff in shared preferences, which is in clear text, it means that people have access to that information in a completely uncontrolled environment where they can do anything to the phone that they want to. You may say that you assume that if it's been sold on eBay, that somebody's wiped the phone, but I think that's probably an incorrect assumption. You've got to assume that nobody's wiped the phone. And unless you're buying them from Gazelle, that the phones have probably not had anything done to them, and a lot of this information will be available. So it's in your interest as a developer to make sure that your users are secure, and that means even if the phone has passed hands 2 or 3 times. Here's an example from Facebook where I downloaded the APK. It has some SQLite information. It had a lot of my messages in SQLite, which I was quite surprised about because it was my inbox messages. This is an old one. I don't know if it still exists, but it's a good example of insecure data storage. So the fix is, don't cache any passwords or social security numbers, which of course, you'd never do that, would you? You wouldn't put any SSNs in there. But there's been lots of examples where people have. We find that a lot of financial apps that they're doing a lot of multi-factor authentication now, where they're asking you for a PIN number, and the PIN number is in a web view. So none of the PIN has been stored on the phone. So you can't get access to somebody's account if you buy a second-hand phone and then root it. Client-server side access control. The whole setup that we have with an Android phone and a backend server really reminds me of the old client-server days. I've been around here for a while. It seems that we've been going through the same examples of the same security snafus that people have been doing for generations now. First it was client-server, then it was web, and now it's on mobile. You know, putting things in clear text is stuff that you wouldn't expect to happen, but I think what happens is that the next generation of developers come up through the ranks and that they haven't lived through the horrors of what we lived through in the past. I really like this. There's a book from Zapata, which is another testing book, which I liked. And it had a little note that said sensitive data should be encrypted and very sensitive data should be stored on the server, which I think is a good way of looking what you should be doing here. If you don't want the information to become public, then don't store it on the phone. Just store it on the server and go backwards and forwards all the time. Use public and private keys. Try not to use AES for your algorithms. Go with an RSA so that you can make sure that the sensitive information is always stored on the server and is never available for somebody like me to find on the phone. Okay, so insufficient transport layer protection. So what we're talking about is just network access now. So the image I have here is it's using a Charles proxy to do a man-in-the-middle attack. There's lots of other ways of doing this. You can use Wireshark. You could use Burp Suite. I'm showing that it's using Proxy Droid to point the traffic at Charles proxy. But you can just change what the Wi-Fi settings are so that it points to whatever the new IP address is, and that'll work quite well too as well. And that allows the server to be able to, the laptop to be able to see what should be going between the Android phone and the backend server. A lot of times when I'm in an environment like this, I typically use a VPN because I'm just assuming if there's a bunch of developers that you guys are all looking at what the traffic is. But you got to be assuming if you're on a hotel network on an airplane that somebody's going to be looking at that if they're over Wi-Fi. So you got to make sure that you're protecting the traffic as it goes. And unfortunately, the news isn't very good. Here's an example that comes from one of the recruiting websites. You can see it a little bit better here, where we did a man-in-the-middle attack and it gave up my username and password. This is from a number of years back, so I'm assuming this is fixed now, but I haven't checked in the last while. So essentially what Charles proxy does and the other man-in-the-middle attacks do is that you load a fake cert and the person isn't handling the SSL exceptions correctly and they're just saying, well, it's probably okay, and they're allowing the traffic to go through. So in Charles proxy, the first level of attack is that you install a fake cert and you pretend to be RIIS.com or Google.com or eBay.com or in this case Monster.com, and it allows you to see what the information is because whoever wrote the code didn't handle the SSL exceptions correctly. So we have on top of that, if you rewrite your SSL code and fix the exceptions so that it errors out instead of just accepting the error and saying, well, it's probably okay, even though it's a fake cert. A number of years ago, there were quite a few root certs that were stolen, which means that the whole SSL hierarchy has kind of fallen apart a bit. What that means is that if you go to Charles proxy, and it is kind of a two-stage attack, you have to download the certs onto your phone. But once you've done that once, Charles proxy can now have access to any of the traffic that's going backwards and forwards. And there's not really much you can do about it because it's not really a fake cert. They're using a top-level root cert, which is allowing them to create certs as if they're VeriSign. So one of the ways of trying to do that is to use SSL pinning, which is a reasonable attempt at doing this, but not 100% secure. Excuse me, what SSL pinning does is that you put the SSL public key within your code, and it says that this is the key that it should expect if the server is RIIS.com or Droidcon.com, HTTPS, and to only ever accept a SSL traffic if the public key matches what you have in your code as the SSL pin. The downside of this is all Android APKs, whether you like it or not, are debuggable, which means that I can turn that off, which somebody nicely pointed out on one of the talks I did before. So it raises the bar, and it is something that you should do, but you should still consider this as not a 100% foolproof situation. Okay, so the fix for the insufficient transport layer. So error out on SSL handshake exceptions. Assume SSL is broken because we had explained about with the root level certs being stolen. SSL pinning, that's a good approach. Do more on the server, and then I haven't tried it myself, but one of Google's recommendations is to scan the server with no go-to fail. So I would recommend starting that too as well. Okay, unintended data leakage. We come across some very strange errors when we look at some apps. So this was not the United Airlines app, it was a different airline when we looked at it. And what it was doing is if you were booking an international ticket, it was writing the passport number to the log file. And while that's not really a problem on anything above, I think, Kit Kat or maybe ice cream sandwich, on the earlier phones, if you asked the user for permission to read logs, that meant you could read all logs. So it's pretty easy to gain access to whatever your log files are writing if you're using a phone earlier than Android 4.0. So don't write stuff to the log files if it's not necessary, and certainly don't write sensitive information such as somebody's passport number to the log file. This is back to the trust but verify again. Make sure that if you install a third-party SDK, that you use. In this case, you can use decompilation for good. So you can reverse engineer whatever third-party SDKs are out there, any of the advertising ones. I think I'm using Millennial Media. It's hard to see on this. But you want to make sure that they're not passing back any information that you don't want your user to be passing back. So there's always a cost when you're using a third-party SDK. So make sure you know what that cost is before you give up some information that your users may not want you to give up. Another thing, what are we talking about now? We're talking about unintended data leakage. This is a kind of a different unintended data leakage. So this is an example from a pharmacy app. And what they did was they didn't obfuscate the code. They didn't use ProGuard. And I'm only saying that because Eric's in the audience. But they didn't use ProGuard. But what they should have done is they should have at least obfuscated this a bit, because now we can see that this person is a big fan of Game of Thrones, that he's a big fan of the Half-Blood Prince of Harry Potter. Some of his variant names are kind of a bit weird there. So we found lots of expletives in code. We found all sorts of stuff. My favorite thing to do is PhoneGap apps. So PhoneGap, it stores everything, including the comments. So if you unzip a PhoneGap app, you can see all the JavaScript, and you can see literally conversations that people are having with each other as they're developing the code about what they put in and didn't put in. And there's a great way to find exactly what style of, this is actually a really good thing for interviewing. When you're interviewing somebody, especially if it's over the phone, download some of their sample apps, reverse engineer it, and you can get a much better idea about what they're thinking and how they code. And sometimes for the best, and sometimes maybe not for the best. Certainly, if I was talking to this person, I'd be going, dude, why don't you just use ProGuard, and we wouldn't have to worry about this. So be careful about what's going on. Unzip the APKs, see what people are putting in your APK and pushing out there to the world. Make sure that you obfuscate it so that you don't find silly things like this, or worse. So the fix is strip out any unnecessary logging code, obfuscate the method names, check any third-party libraries, double check your WebView caches. A lot of times when we do this, the audits, we use a number of interns come in every summer, and one of the things that we try to train them on is how to write secure code. We're looking for a very particular type of person, and we find that if they're really good at this, they tend to be good developers afterwards. And one of them was really good at finding information in web views. So I hadn't really paid much attention to web views. I thought the cache just disappeared after a while, but you'd be surprised how long they hang around. We found credit card numbers, we found CVVs in there. Be careful about what you're putting in your web caches, and make sure that you delete the information immediately after you need it. And as I said, download and unzip your APK so that you can find out what's really in your APK. So poor authorization authentication. This is, as I said, this is really good news when I see this, when I'm looking at an audit, because it means that somebody's storing something that they shouldn't be. This is a ticketing application that we found. This is 3 or 4 years old now, where we found that the username and password was stored in clear text in the shared preferences. The latest, what happens then is we report this, and then we get another app that comes back after about either 6 hours or 6 months. There doesn't seem to be any way in between there. So it's either immediate or they just do it in the next release. So usually what happens after that is they encrypt it, and they'll encrypt it, and we'll talk about that in the next section. And they use AES, which means we find the key, and then we decompiling it using the key, because all the information is there on the phone. The next level after that you'll find is that they'll use a key, but they'll have a dynamic key. But because we have access to the code, all that we have to do is figure out what the recipe is, which probably means putting it in debug mode and setting a few breakpoints, and then we just decompile it again. So what you should do is skip all those steps and just go to RSA public-private key. Okay, so no password caching. If you can have some sort of a multi-factor authentication, that's a really good way to go. Encryption, public-private key exchange. Be very careful about tokens. Back in the early days, there was a lot of social media apps, and a lot of social media SDKs whose examples gave you tokens that never expired. So when the person used, I'll say it again, Facebook, I see they're over there. Whatever, used Facebook to log in, it didn't expire it, so I'm sure it's fixed now. Just make sure that you know how they expire, and don't make sure that it's 30 minutes or whatever it is that your business users will put up. Certainly don't let them stay there forever. Expire them after some level of time. A good way to test that is if you take your phone and back it up and then put it on another phone and see if you can log in. That probably tells you that your tokens are not what they should be. Just expire them as quick as you can. What makes sense for you? I know on mobile phones that people tend to expect that your token should stay around forever, but that's not really feasible. You have to expire them at some stage. Another thing that we use a lot on APIs is to use one-time nonces. So the server side will give you a nonce, which will give you access for a certain period of time, and it's either attached to the IP or attached to some other multi-factor authentication, which means that you, if you put it to another phone, that you can't use that phone to gain access to. So cryptography. So when we started this off, a lot of the problems that we saw after people got by putting the password in clear text was that they would put the password in SQLite in the database. Or they would, one example that we saw which was quite entertaining was that they put it encrypted in SQLite in the database and then still left it in share preferences in clear text. So you got to make sure that one side of the company is talking to the other so that whoever is coming in, or do some sort of a code audit, so that whoever is coming in is not bypassing whatever security systems they put in place before. So here we have an example of my password. This is on the Delta app. It's stored as encrypted in SQLite. But because they're using AES, I can just look to see what the code is. And then I just basically take that code, cut and paste it, and then just run it against because I have the key, I can just run it against the password in the SQLite, and that gives me back what the password is. So AES is dangerous. You got to make sure that you know what it's doing. And also obfuscated, so it makes it harder for people to see. I know that people in certain times will say that obfuscation really doesn't gain you much, but developers have been taught for years and years and years to write clean code, to make sure that they're doing things the right way, to make sure it's maintainable, to refactor it, to have very low code complexity so that the next person who comes along can understand how your code works. But if that next person that comes along is the hacker, you're making it really easy for them. So it's almost like we need to defactor the code before you get it out into the public. And one of the best ways to do that is to use ProGuard or DexGuard, or there's a -O, there's many others out there. You may also want to try and use the NDK, and we've seen people try to hide passwords in the NDK. The NDK is a great place to start putting a lot of your important information, not your very sensitive information, but your sensitive information. If you write a large enough NDK file, I would hazard to guess that even if you had the original source code, it's really difficult to understand. But still be careful. You can disassemble it. And if you can disassemble it, I can look at it in hexedit. And in this example, we found an API key. It's been changed a little bit to hide who it was. But this is a good way of at least starting to get some information in a place that makes it harder for you to gain access to. You put it in the NDK, it's now a shared library. You can put some restrictions to make sure that only your APK can call that shared library, and away you go. I had to put a Starbucks example up because everybody loves to hack Starbucks. I think it's because reporters go to Starbucks, so every time that somebody tries to sell them a story with Starbucks, that's the first thing that comes to the top of the pile. What we did here is Starbucks were using SQL Cipher, and they have a key that was being used to encrypt SQL Cipher. It was a really long, complicated recipe, but it was pretty easy to figure out how to put that recipe together, even though it was in 3 or 4 class files, because they didn't obfuscate the code, and because all the information was stored on the phone, and there was nothing that was stored on the server. And then once you get access to SQL Cipher, we did a simple update to change whatever the card value was. I'd be very surprised if this worked in real life, because I think there's actually some sort of 2-factor authentication that was going on the back end with Starbucks system. So, but the lesson here is if you're using SQL Cipher, be careful about how you store the key. It's best to have a PIN or something auto-generated each time rather than just using a key that everybody can gain access to. So the fix is to go to public-private key. So there's lots of examples out there. There's lots of tools. There's Keysar, there's Spongy Castle. There's lots of things out there that you can use that will help you get secure your person's information on the server And then if the client wants to use it, then basically what you're doing is you're passing it over only when it's necessary and it's in memory and there's nothing ever stored on the phone. Okay, so use asymmetric encryption, encrypt your databases. I put a resource at the end because we were using Android Key Store a lot, and then another intern found a paper that showed how to break Android Key Store. This was in 4.0, so it won't work on any of the encrypted devices, but I think that I read this morning in a Daily Express article in the UK that only 10% of Android phones are encrypted. So when encryption comes to the vast majority of Android phones, this really isn't going to be as much of a problem, but we've still got a ways to go before we get there. Okay, client-side injection. So if you're using any web views, the same sort of security issues that apply on the web also apply now to your phone. So I'm using this, the classic little Bobby Tables example here. So what we're trying to do is we're looking at, we're adding an extra bit to the string. So your select now becomes select star from login, where username equals nothing, or 1 equals 1, which is always true. So basically that gives me full access. So just like you would do on a backend server, you got to make sure that you're using some sort of a parameterized query so that somebody can't attach something to your select statement and get access to things using SQL injection that they shouldn't be getting access to. What's old is new, and what's new is old again. Web views, I've gone to a number of talks where people have talked about JavaScript and all the wonderful things that you can do with JavaScript and web views. I would say be very careful, and if at all possible, if you're using web views, set your JavaScript enabled, set it to false so that you don't gain access to any of the JavaScript. The best way to test that is if you have a button or a form, put script alert and see if it comes up and shows you that you have a cross-site scripting attack that you can do in there. And if you do, then you probably should set JavaScript enabled equal to false. So the fixes here are use parameterized queries and set JavaScript enabled to false. A slightly more esoteric example now. This is using intents to gain access. So in this example here, we have a login screen, and all it's doing is just passing the information to the next intent, to the next activity. The way that we do that is that we tell our first main activity that it's going to be talking to the second activity, so that it knows that it's passing control. Pretty basic Android stuff here. But if you don't use explicit intents, there's no other reason why somebody else can't gain access to your intent, and see if they can create some confusion with the user and give them a choice. And choices on Android users are not exactly great, so they're 1 out of 10 will probably hit the wrong choice, and it will get taken over by the second app, which is looking to see if it can gain access to your username and password on your login app. So the best way to do this is to make sure that you're always using explicit intents instead of implicit intents. There's an app out there that's in the resources called Intent Sniffer, which will give you lots of information on what intents you probably want to lock down. But this is just a refactoring job. It's something that you could probably do in 5 or 10 minutes. I haven't seen many attacks that have used this yet, but it's part of the OWASP top 10, so we're going to just cover it anyway. And as I said, the app is called Intent Sniffer, the resources at the end. So improper session handling. So this is back to the device always being permanently authorized, as you can see at the top here. So what happens here is that somebody is essentially saying that the device is always authorized. I don't really care. I know what the device ID is because the device ID is in the shared preferences. You need to make sure that you're expiring the sessions in some shape or form. This is an example from another social media app, so not that I'm picking on Facebook all the time. This one came from Tumblr, and Tumblr is basically what they did is they left an auth token in there, which meant that I could just take that, pass it to another phone, and gain access. Now, ADB backup works on most phones. You don't need to be rooted, so I can take the information and pass it to another phone and then gain access to that person's phone. Like I said, it still means that you need access to the person's physical phone, but there's lots of times it doesn't really take much for people to gain access to phones. Plus, as I said, so many phones are sold in the secondhand market that we got to be worried about this too as well. I could see a use case where somebody would go through all the hacks that are out there that people know and target specific phones and just run through 100 phones to see which ones they could pull the information off. So expire sessions. If you want to try it on your own app, back it up to another phone, and be very careful about using OAuth logins and exactly what they're doing, so that somebody else can't gain access to information that they probably shouldn't be gaining access to. I'm going to talk a little bit about obfuscation here. So what I did is, we used to do a lot of telephone apps back in the day. It's a voice over IP app called SIP Demo, which comes with, I think it was back in API 17, some of the Google samples. In here, it's it's a sample app, so you don't really expect it to be very secure, but it's a good way of showing how obfuscation works. So it's in this case, it's storing the username, the password, and the domain. So the way that a SIP phone works is that your phone is talking to a backend server. It's like acting like a desktop phone. And if you have a username and password on the server credentials, you have gained access to whoever that phone number is. You can make international calls. You can call all the numbers in the Bahamas and rack up their charges. This is not something that you would want to happen if you're creating a SIP client. Okay, so the three examples that we have here, the first one on the top left is when I decompile that without any obfuscation. As you can see, it got the name preference, the domain, and the password are still in there. The one below is using ProGuard, and you can see that it's changed a lot of the method names, but I can still make out, just because of the way that Android works, that the name and the username are being stored. The password preference has been stored in the preferences file. The third one is using DexGuard. So not that I'm trying to sell DexGuard licenses for Eric over there, but really what I want to point out is make sure that when you use obfuscation that you check what it does. And if it's not obfuscating that you expect it to, then change the settings. There's lots of things that you can do when you download the ProGuard SDK outside of what you do in Android, which will allow you to tweak it really easy using a GUI. You don't have to learn the kind of arcane language that's within ProGuard config files. Always check to see what the obfuscation is, because you may be surprised that it's not doing what you thought it was going to do. And just so that I'm not trying to oversell the DexGuard stuff, there are several out there. There's another commercial one from Preemptive called Dasho, and there's many others out there at the moment. But my favorite is DexGuard. Okay, so the fix is obfuscation does help to remove useful information that the hacker would like. So, to enable it, you just set minify enabled equal true. It's not a silver bullet. There are anti-ProGuard apps out there. Another thing that we always hear is that hackers will just move to Smally. Smally is the assembly level language that is pretty easy to work with once you get used to it. It does require kind of a strange obsession with bytecodes again, but it is quite easy to use once you get used to it. But it's another layer. It's a different type of person that you're trying to protect your apps from. Currently, if you're not using something like ProGuard, you're just allowing people to decompile your apps, and you're not putting any obstructions in the way. You might want to think about coding in C++ and using the NDK. It is much harder to read the NDK, but we have a lot of success hacking iOS apps. And we don't have access to the code hacking iOS apps, but there's a lot of ways for us to just reverse engineer an iOS app and to step through it using many of the tools that are available, and just search for the key. It's going to be a certain size, so there's lots of things that you can do. So disassemble it yourself and make sure that whatever you put in the NDK is doing what you thought it was going to do. Okay. So I'll try to rip through this as quick as we can. What's new? JADX, Android debuggable is always equal to true. We talked about SSL pinning and bug bounties. So I'm showing an example here of the United app where we made it debuggable. There's a really good URL at the back which shows you how you can make any APK debuggable. Essentially what you have to do is you just have to add an extra line into the Smally code. So you use APK tool to unzip it. You add the extra line, you zip it back up again, and now it's debuggable. Here's what you have to do to go down to do it. I'm not going to go through it, and I'm not really going to talk much about Smally because I don't have a lot of time. But if you want to do it yourself or you need any help, more than happy, send me an email. If anybody wants us to look at any of their apps, we're more than happy to take a look. The first one's always free. Okay, so if security is too difficult to keep up with, then you can crowdsource it with bug bounties. United Airlines really pushed this a lot, offering substantial air miles. The lessons learned, because it's a year now since this has been going on, it requires a lot of effort to keep up with submissions. Somebody needs to be dedicated to keeping up with the bug bounty submissions, because there's nothing that ticks people off more than submitting all these errors and finding out that they've already been submitted by somebody else. So make sure that you keep everybody up to date on what's been submitted and what hasn't been submitted. And better still, just release new APKs as quick as you can with the fixes that you have. So make sure that you have a dedicated team for bug bounties. Don't just assume that it's going to happen. Because what happens is the researchers just get fed up and go off somewhere else because there's plenty of other people on bug bounties out there that they can go after some money for. And another caveat, this is not a tool for shutting down researchers. And I don't say this lightly. I know for a fact that a certain company is using this to shut down researchers. So basically what they're doing is you can't say anything if you want to get a bug bounty. So it basically stops the information from getting out in the public. But sooner or later it's going to get out there. So try not, use it for good, not for evil, I guess is what I'm trying to say. Okay, so reasons to ignore security. These are the things that I hear a lot. So security is too difficult to keep up with, so you might want to look at bug bounties. Requires physical access. We already talked about the Avast report. Allow backup equals false. It's a Linux system. I can root it. If I get access to it, I can get access to anything. ProGuard, DexGuard is too hard to use. Minify enable equals true. Gradle is wonderful. It's easy to use. The code is already obfuscated. It might be, but you got to check that the bit that you need, that you're trying to protect, is obfuscated, and that whatever name preferences and usernames and passwords, like I showed earlier, are not in the clear so that somebody can't get him access to it. You need to talk to the API team. So we find something in your app and it's the API team and not you. You got to make sure that you collectively take responsibility, that somebody has the big picture and just doesn't shove it off to somebody else. We found a fairly major bug and then somebody said it's the API team. Don't know what to say to you guys. But you got to make sure that collectively you take responsibility. Fragmentation, just because it works in Lollipop and Marshmallow doesn't mean that I can't hack it when it's on Gingerbread and you're still selling it in Gingerbread. Make sure that you're testing it on all the other phones. Log files are something that's a problem. There's lots of things there that you want to be careful of. And then we don't have the time. Financial applications have the time. We did an audit of credit union apps. We couldn't find anything of the top 10. So credit unions are doing it, banks are doing it. There's no reason why everybody else can't do it too. Recommendations. Understand debuggable equals true. Allow backup equals true. Don't trust verify. Rewrite your SSL code to handle exceptions. Use asymmetric, not symmetric encryption. Allow, if you have an email on the Google Play, answer the emails. There's nothing more frustrating than when we send something and the emails kind of disappear into a black hole. Attacks are going to get more complex. This is the easy stuff. Start a bug bounty. Store nothing important on the device, and don't ignore smelly attacks. And secure your server as well, because a lot of times we find that people don't secure their server. Here's a bunch of resources. I'm not going to go through them because I'm out of time. Here's the good stuff. So what we did was, here's the gist of all the old hacks that we've done. If you want to test them, you're more than happy. Each of these gists is basically the information that we sent to the company that told them what was wrong with the app. And all of these have been fixed. But if you want to go to APK Pure, you can find the old APKs if you want to see the examples that we're showing out here. And it's pretty good. Just install them on your phone. It's a great anti-pattern to learn from about how not to do things. So we're not really exposing anything. This is old stuff. But it's still pretty interesting. And here's the contact details. So I guess I'm over time already. I ripped through that really fast. Anybody got any questions? Nothing? OK, one here. Yeah. REST assumes it's secure? Is there a way to avoid using a token base? If you're trying to secure REST, the question is there a way to secure REST? Is that what I'm hearing? The best way to do is go to the OWASP top 10 and look at what it says about how to secure your server. There's quite a bit in there about how to secure REST services. That's what I would recommend. Anything else? Sorry, I know that was really fast, and it doesn't help that I'm Irish, so I'm sure the accent didn't help either. But thank you for your time. Really enjoyed it. Cheers.